Welcome back to class once again. In today's physics, we'll be discussing about scalar and vector quantity. Meanwhile, I told you earlier that the O3 School app is quite available in your Play Store. Please do well to download and also subscribe or activate so that will enable you to access questions and solutions. All right. Today we'll be talking about scalars and vector quantity. Scalar and vector quantity. From what we have been saying so far in the previous videos, we talk about position, distance, and displacement. We'll be making mention of displacement as a vector quantity. So today we are going to be seeing more on the vector quantities. Now, the vector quantities have something called numerical value. That is, they have magnitude, they have size and direction. They have magnitude and direction. Why scalar? They have magnitude but no direction. So let's see, scalar. Scalar, you talk about distance. Scalar, you talk about distance. Distance, mass, area, volume, temperature, money, even money. Mass, you have mass, the quantity of matter contained by a body, area, volume, temperature, hotness or coldness of a body, money, the one you call lega, tender. All right. Then we also have energy. Energy. We also have power. Energy, the ability to do work. Power, the rate at which work is done. Okay. Now, these are, they also have speed. Yes. Speed, talk about distance per unit time in an unspecific direction. So these are all scalar quantities. We can equally have density. Yes, density is also a scalar quantity. They have magnitude but no direction. For example, we can add volume of maybe 3 centimeter cube, 4 centimeter cube, 9 centimeter cube. We can add them together numerically. So scalar can be add numerically in form of 3 plus 4 plus 9. So you have 7, that is about 16 centimeter cube in the case of scalar. But in the case of vector, their direction have implications because their direction in terms of maybe backward, negative, forward, positive. So the directions are put into consideration in terms of vectors. But for scalar, their numerical values can just be added. For example, I have money. I can decide to say 20 naira plus 1 naira. So I have 21 naira because directions, they are not put into consideration. So these are for scalar. Now, temperature. Temperature has magnitude but no direction. Temperature, they mostly occur in the measuring scale of the thermometer. The thermometer, they are mostly instruments to measure temperature, either the hotness or coldness of a body. So we can have a temperature of 20 degrees Celsius, temperature of 40 degrees Celsius. So they are just placed in the body of such instrument to tell us about the degree of hotness or coldness of that body. Then money is a legal tender used for transaction. So temperature, money, speed, these are all scalar quantity. And I said scalar can be added numerically. It's just addition of what? just summing the quantities or the numerical values together. So you have 20 naira plus 1 naira, you have 21 naira. But in the case of scalar, in the case of vector, vector can be represented in form of either using the polygon method, parallelogram method, or graphical method most times. So for the scalar quantity, does not undergo maybe a polygon representation or parallelogram representation. The reason is that vector quantities are mostly described using relative term or angles in degree. They are mostly represented with what? Angles in degree, or using relative what? Relative term. That is why the use of the polygon or the triangular laws, they are coming in place. All right, now let's see for vector quantities. Now for vector quantities, they have magnitude and direction. They have magnitude and direction. So vectors, examples of vectors. One, we talk about force, weight, magnetic flux. Magnetic flux, they are established in a magnetic circuit. Then you have force, you have weight, acceleration. Acceleration is a vector quantity. Then velocity. I told you before that the difference between velocity and speed. Similarly, velocity and speed, they are measured in meters per second. But the difference is that velocity is displacement per unit time in a specific direction. We are calling on specific, we are making mention of specific direction because it's a vector quantity. Then momentum. Talk about momentum. Then momentum, friction, etc. rather. So these are vector quantities. So vector quantities, they have magnitude and direction. Maybe for example, let's say I have something in this form. Let's say this is point P and I have a force of 10 Newton. Then acting at an angle, let's say at an angle theta to the x axis. So this force is a vector in the direction of what? Acting in the direction of theta. So let's say force 10 Newton moving in the direction of what? Of theta. Force 10 Newton moving in the direction of theta along the x axis. Along the x axis. So we can see the direction. So that is force. Or it could even be velocity. I can decide to say 10 meter per second. Or I can decide to make use of which other parameters? Momentum, or maybe acceleration of a body acting at an angle, etc. All right. So vectors, one common thing about vector is that they have magnitude and direction. The direction is given by the angle, either by the angle or relative term. What is that relative term? As I've earlier said before, under displacement. Okay, among the vector, we also have displacement. Yes, displacement. So we can have, I made an example before, along this horizontal axis. Let's say we have the point of origin, 0, 1, 2, 3, 4, 5. If a train let's say this a train moves from point P here to point A for a distance of 5 kilometers. Now, this is the initial position, and this is the final what position. Now, if the train moves back to its initial position, the displacement becomes what? 0. Because if we take forward to be positive and backward to be negative, so that means 5 minus 5 will cancel out. And when they cancel out, the displacement becomes 0 kilometer. Unlike distance. If you are to be distance, I told you earlier that distance will give us what? 10 kilometers, because from here to here is 5. Now going backward back to this point P again, we have 5 kilometers. So 5 kilometers plus 5 kilometers, we have 10 kilometers. But the displacement is 0 kilometers. So displacement has magnitude and direction, while distance only have magnitude but no direction. All right. Now, how do you add vectors? I said it before. How do you add vectors? Let's say we have vectors in this form. Addition of vectors. Addition of vectors. Now, if vectors are moving in the same direction, you add. But when vectors are moving in opposite direction, you subtract. So let's see, for example, addition of vectors. Let's assume we have something in this form. A force of 5 Newton. Then another force of 2 Newton. We need to add these forces. So that means if we are to add, they are moving in the same direction, so we add. So this will give us 5 plus 2. We have 7 Newton, because they are moving in the same direction. Now, if they are moving in opposite direction, let's assume we have this vector to be 10 Newton. Then we have another vector to be 2 Newton. Now, the vectors, they are moving in opposite direction. So if we take this to be positive, we take this to be negative. So therefore, the magnitude of this vector becomes 10 minus 2. 10 minus 2, so we have about 8 Newton. That is how to add vectors. Now, you see, the magnitude is put into consideration, and the direction is also put into consideration. What is that direction? As I've earlier said, I said it before, that the relative term. What is that relative term? Moving maybe upward, positive, and moving downward, negative. Or moving to the right, or moving forward, positive. Moving backward to the negative. That shows the direction. The values you have here to be 10 is the numerical value, numerical. Then 10 minus 2, we have 8 Newton. Now, there's what we call resultant force. What is a resultant force? Resultant force is just a single what? Force. It's a single force. When you have multiple force coming together to form a single force, that becomes a resultant force. For example, I need a force of 40 Newton. Let's say I need a man that has a force of 40 Newton to push a car. Now, if I have 3 other persons maybe 20 Newton, 10 Newton, and 10 Newton. This is a single man now. The entire force coming together by these three persons, 20 Newton, 10 Newton, 10 Newton, to form this 40 Newton. This single man with a force of 40 Newton has the resultant force in combination of these other three persons. So that's the what? That's the resultant force. Now the same task executed by these three persons can equally be executed by this single man. So the single man has the force of 40 Newton, is the resultant of these three other forces. So that is the resultant force. Okay. Now, what happens when forces are placed at an angle, either at right angle or maybe at an angle of theta? So that's where the law of you can employ what we call the cosine rule. The cosine rule, which says that maybe a square b square plus c square minus 2ab cos a. Then you must also put into consideration your Pythagoras rule, a square b square plus c square. All right. Let's see some, before we solve problems, vector representations. How do you represent vectors? Vector can be represented either graphically or analytically. Now, graphically, or you analyze using what? Either we can use polygon law, the polygon law, or the triangular law, or the parallelogram law. Now, for today, we're going to base our concentration on the parallelograms law of vectors. Now, the parallelogram law of vectors states that the law states that two vectors simultaneously possesses two uniform velocity represented in magnitude and direction. By the adjacent side of a track of a parallelogram. Drawn from a point. All right, so the law states that two vectors simultaneously possesses two uniform velocity represented in magnitude and direction by the adjacent side of a parallelogram drawn from a point. Now the resultant is represented in magnitude and direction by diagonally passing through the same point. I'll talk about diagonally. For example, I have a rectangle like this. This is a rectangle. Divided this into two, form two triangles. So this line is where the resultant is. So that's the diagonal line. Now coming back to parallelogram, we have something in this form, two velocity. Let's say this is U, and we have V. We have V, U and V. Okay. Parallelogram. If this is U, opposite side of a parallelogram, they are opposite. So this is U, this is equally U. Now you have a resultant at the diagonal at an angle theta. If here is theta, this small part, let's say is gamma, and this is R. Now if I have these two vectors acting at an angle theta, that the diagonal of this parallelogram gives us the resultant. We're interested in the resultant, yes, because the resultant gives us the magnitude of that vector, of these two vectors. Then the angle gamma gives the direction, because every vector, they have magnitude and what? And direction. So we are more interested in the magnitude and the direction. So let's analyze. Now, how do we, mathematically, I can decide to create a triangle here. This is a right angle what? Triangle. So let's say this is A, B, C, and D. My R here is the resultant. If this is U, this is U. If here is V, this is V. So I have a resultant. This is my resultant. If here is theta, definitely here will also be theta, alternate angle. Now the sum of angle on a straight line is 180. If I need to obtain this place, I'll cut this place. This is angle on a straight line. Angle on a straight line, something like this. I have here to be X. If here is X, for me to get here to be 180 minus X. Angle on a straight line is 180. So definitely here is 180 minus what? Minus theta. Now if this is 180 minus what? Minus theta. So here is gamma, here is R. So definitely, if here is theta, that means that vector U has two components. What are the two components? The vertical component and the horizontal component. Now, what's the vertical component? This is U. This is U, vector U. Now, when we talk about horizontal component, that means here become U cos theta, horizontal, U cos theta. Then when we talk about the vertical component, it becomes U sine theta. Now, you must also know your SOHCAHTOA, that tan, if we are considering ACD, tan theta is opposite over what? Over adjacent. Now, if I need to get my resultant, for me to get my resultant, I consider what we call the cosine rule. The cosine rule. You employ cosine rule when the triangle is not a right angle, mostly a scaling. Scaling means the three sides of the triangles, they are not equal. So definitely, my resultant is AC. My resultant is what? AC. So if my resultant is AC, AC is equals to R. So therefore, my other two vectors is U and V. So R square is equals to U square. I'm having what? U square plus V square minus 2UV cos theta, or R square equals to U square plus V square minus 2uv. No, I can decide to use plus, but this time to be cos 180 minus theta. The reason is that in the second quadrant, you were taught in mathematics, in the second quadrant, cos is negative. Cos is negative. So definitely 180 minus theta, I'll have a negative value. So if I have negative value, so negative minus times plus, I'll have minus. But if I decide to use theta, I'm using minus at this point. So don't be confused. For example, I have a value of 135. Because 135, I'll be having a negative. So that negative times plus, I'll have minus. So this is how to get the resultant of that two vectors acting at an angle. So two uniform velocity u and v represented by the vector a, b, and ad respectively is what we have. So parallelogram law of vector states that two vectors simultaneously possess two uniform velocity. What are those velocity? U and v, represented in magnitude and direction by the adjacent side of the parallelogram, drawn from a point, this is the point A, that the resultant can be obtained by the what? The line, the imaginary line that cuts across the diagonal of the plane. What is the plane? Which is the parallelogram. All right. Now, how do we get gamma? Now, we know how to get the resultant. Now, this is how to get resultant. The next thing is, how do you get the direction? You can get the direction using what? Gamma. So let's find the direction. Now, for us to get the direction, we consider triangle. We consider triangle ACD. ACD. It's a triangle. All right. Now, since it's a right angle triangle, because we are considering ACD. ACD. So what do? We have opposites. We have opposites. We have adjacents. We have hypotenuse. So we can decide to say, okay, tan gamma, because gamma gives the direction in which the two vectors moves. So tan gamma is opposite over what? Adjacent. Now, what is the opposite? Now, the opposite is the vertical component of u. The vertical component of vector u is u sine theta, while the horizontal component is u cos theta. So definitely the opposite is u sine theta. Now, what is the adjacent? Now, adjacent is AD. AD. That means the opposite is DC. So we can say, okay, DC over AD. Now, DC over, what is AD? AD is, let's say here is N. AD is AN plus ND. So AD is AN plus what? ND. Now, what is DC? Now, DC is u sine theta. What is AN? AN is V. So you place your V. Plus ND. What is ND? ND is u cos theta. U cos theta. So we now have tan gamma. Tan gamma. Now, how do we get gamma? We take the tan inverse. Now, for us to get gamma, we take the what? The tan inverse. So therefore, Gamma is tan inverse, the tan inverse of what? U sine theta over V plus U cos theta. So this is how to get the direction. The direction. From the parallelogram law, the direction of the two vectors acting at an angle theta can be obtained in this form. Okay, so let's see some problems to clarify our provings. All right, okay, we have one here. Before we take questions from the app, let's see what we have here. Now, based on parallelogram law, it said two forces, 10 Newton. Two forces, 10 Newton. So let's say F1 is 10 Newton and F2 is 20 Newton. Are inclined at an angle of 60 degrees. That means theta is 60 degrees to each other. Find the resultant. So we have two forces, F1 and F2. They are inclined at an angle of what? 60 degrees. So let's see the free body diagram of the two bodies. Okay. Let's say we have the first body. This is F1. Then second body. They are acting at 60 degrees. And this is the second body. And this second body is F2. So we have F1 and F2. So if they are inclined, how do we get the resultant? For us to get the resultant, we can complete, since it's acting at 60 degrees, 60 degrees is less than 90 degrees. That's an acute angle. So definitely we can have a parallelogram because the resultant will give us the magnitude. So we can divide it. So the diagonal gives us the resultant of these two forces. Therefore, if this is F1, definitely this is F1. If this is F2, here is equally F2, opposite sides. Now, if here is 60 degrees, this angle will be 180 minus 60. Okay. If we have a right angle triangle, if this is 90, definitely, if here is 60, here will be 60 degrees. Now, the direction. If we're also interested in the direction, the question says the magnitude, but if we're also interested in the direction, so let's cut here. Here can be our what? Our gamma. The gamma will give us the direction. All right. So we can now name here A, B, O, C, and D. So that we can get our resultant. Now the angle we have here is 60 degrees. So definitely we're going to introduce the cosine rule, which says that the resultant is OB. So OB square equals to OA square. OA is F1. So OA square plus, we need OC square minus OA times OC, then cos 60 degree. Cos 60 degree. Okay. Use our calc. All right. Now, F1 from the question, F1 is 20 Newton and F2 is 20 Newton. Okay. So this is 10. This is 10 Newton, while this one is 20 Newton. So we have OB is our resultant. So R squared, OA is 10 squared, OC 20 squared, minus 2 times 10 times 20, then cos 60. Cos 60 is 0.5 because sin 60 is 0.866. So R squared, 10 squared is 100, plus 20 squared, you have 400, minus 2 times 10, 20 times 20, so 400 cos 60 degree. So R squared gives us 100 plus 400, so we have 500 minus 400 cos 60 plus 400 times 0.5. And 0.5, you have 1 over 2. So definitely the resultant becomes 500 minus 200. 400 times 0.5, you have 200. So therefore we have 300. So we take the square root of both sides. So definitely square root of 300, you have 10 root 3. So you have 10 root 3 Newton, or 10 times 1.73. That's 17. Okay, so you can go with 17.32 Newton. That's the resultant. The question says the resultant. So if you need the direction, you can plug in the formula we proved the other time. All right, let's see more problem. All right, this one is from, that's that for this. The answer is 10 root 3. The next one is from JAMB 2011. We have, it said the diagram above shows 2 vectors. JAMB 2011, question 5. The diagram above shows 2 vectors at right angles to each other. The value of the resultant vector is dash. So this is the diagram. You have 2 vectors. Since they are acting at right angle, that means they are perpendicular to each other. This is 6 Newton and this is 8 Newton. So for you to get the resultant, you can get the resultant in this form. This is resultant R. Now if that is the resultant, use Pythagoras. So employing Pythagoras rule, because the square of the longest side, you have R squared is equals to 6 squared plus 8 squared. So definitely you have 36 plus 64. So R squared is 100 Newton. So R is square root of 100. So you have 10 Newton. So the resultant is 10 Newton. So the options there is C. Answer there is C. A is 13 Newton. B is 14 Newton. So the answer is C. That is that on that, C. Yes, we can as well get the direction, but the question did not demand for direction. But just know that vectors, they have magnitude and direction. Okay, then we have another one. Said 2004, JAMB 2004, question 10. It said if the angle between two vectors P and Q is 0, the vector are said to be dash. A, be perpendicular. B, they are parallel. C, interested at angle 60. D, intersect at angle 45 degree. So when two vectors is acting at 0 degree, two vectors acting at 0 degree, there's no angle linking the two vectors. So they are said to be parallel. They are said to be the parallel. So we have option A there, perpendicular. The answer is B. When two angles are 0 degree, it means the vectors, they are in the same direction. Look at what is on the board. They are in the same what? They are in the same direction. So they are said to be parallel. So therefore, the correct answer there is they are parallel. So that's that on question 10. Then we also have 2001 question 8. It said the resultant of two forces acting on an object is maximum if the angle between them is dash. Two forces acting on an object is said to be maximum if the angle is 0, and hence the forces are acting in the same direction. So the resultant of two forces acting on an object is maximum if the angle between them is 0. The angle between them is 0. Set to be what? Maximum. So the option there is C. Okay, let's solve more complex problem. All right, we have this. Okay, we have this. A boy running in the northern direction later changes. Let's see. A boy running in the northern direction later changes his direction and started running towards the eastern direction. A boy running in the northern direction later changes his direction. So let's say the boy is here. The boy is here. The boy running northern direction. Running northern direction to create another cardinal point. Now, a boy running in the northern direction later changes his direction and started running towards the east direction. So the boy is now here, is now running towards the east direction. Now, if the distance he covered in the northern direction is 4 kilometers, so here is 4 kilometers. When he was running towards the north, 4 kilometers, then immediately he changes and started running towards the east direction. I repeat the question. A boy running in the northern direction later changes his direction and started running towards the east direction. The boy is here. Let's say this point A, you have the boy here. The boy is running towards the northern direction for 4 kilometers. Immediately he changes. This is north. He changes and started running east, the eastern direction. Now, if the distance he covered in the northern direction is 4 kilometers and in the eastern direction is 3 kilometers. Now, the question says, determine the magnitude of his resultant and his direction. So we are interested in the magnitude of his, determine the magnitude of his resultant and his what? Direction. So we can decide to say, for us to get the magnitude, so this is the resultant. If that's the resultant, this is 90 degree. So definitely Pythagoras will come to play. R square equals to 4 square plus 3 square. So R square, what is 4 square? 16 plus 3 square is 9. So R is square root of 25. So definitely we have 5 kilometers. That's the resultant. Now the next thing is to get the direction. The direction, let's say here is beta, angle beta. So if angle beta is there, for us to get beta, we have opposite, we have adjacent. We have resultant to be 5. We can use any of the SOHCAHTOA, we'll get the angle beta. So let's decide to try this. If we decide to use tan beta is opposite over what? Adjacent. So definitely opposite over adjacent. What is opposite? Our opposite is 3. Opposite is 3. Then adjacent is 4. So that means 0. If we have 3, so that will give us 0.75. So beta is tan inverse of 0.75. So tan inverse is giving us 37 degrees. Or still, we can decide to use sine. If I decide to use sine beta, if you don't want to use tan, you can use sine. If I use sine beta, I have opposite over what? Hypotenuse. Because from SOHCAHTOA, sine is opposite over hypotenuse. So sine beta is opposite over hypo, and the opposite is 3 over 5. So if we have 3 over 5, that's about 0.6 sine beta. So beta is sine inverse of 0.6. So we still have beta to be 37. So whichever method you intend to use, you still arrive at the same answer. So the resultant, hence, resultant, the magnitude in form of the resultant is 5 kilometers. The direction, beta, is 37, approximately 37 degrees. So that's that on that. Okay. Okay, we still have some questions. Okay, yes. Physics 2017. So let's see, on JAMB, we'll also take some from, okay, let's see JAMB 2017, question 12. It said a man walks, or rather a man moves 4 kilometers southward. So let's say the man is here. The man is right here. The man is here. We have north, south, west, and east. A man moves 4 kilometers southward. So this is, he moves to the south, 4 kilometers. So he's not here. What happened next? Then 5 kilometers westward. He now moved 5 kilometers. 5 kilometers west. When you are here, this becomes the new north, your new east, new south, new west. So 5 kilometers westward. He's not here now. Now what happened? A man moves 4 kilometers southward. and then 5 kilometers westward. And finally, 4 kilometers northward. You move to the north again. North, 4 kilometers. It moves to the north. You must put your direction. In showing vectors, you must put direction. Now the question says, the displacement of the man is dash. A, 5 kilometers eastward. B, 5 kilometers westward. C, 13 kilometers eastward. Now if you check, this is 4 kilometers, this is 4 kilometers. They are moving in different direction. This one is going southward, this one is going northward. So that means opposite direction. I've taught you before, opposite direction of a vector, you minus. So that means 4 kilometers, this one is going to the south, minus 4 kilometers, this one is going to the north. So that means they will cancel out. The magnitude of that vectors will cancel out. So what you have left is 0. So the displacement is just 5 kilometers westward. So the answer is B. What you have left as the displacement is 5 kilometers westward. So the answer there is B. Okay. Let's see. 2023, question 8. Of 2023, question 8. It said a car is moving at 50 kilometers due east. You have a car. It's moving 50 kilometers per hour due east. So this is your east. A train, they will have another train. This is a car. This one is car. They will have train. A train is moving 70 kilometers due west. So you have due west. So 70 kilometers due west. Now, they say, what is the relative velocity of the car with respect to the train? Now, mind you, when you hear the word relative velocity occurs between two bodies, not a single body. We can have a random motion on a single body. We can have an oscillatory motion between a single body. But when it comes to relative motion, it's on two bodies. So let's say this is the VC and the VT. What does that mean? VC is the velocity of the car and VT is the velocity of the train. Now, moving eastward, we can take eastward to be positive because we are talking about vectors now. Relative term. I keep saying this, relative term. What is that relative term? Moving forward, you may take it to be positive. Moving backward is eastward, which is what? Negative. I can decide to have my own sign conventions. What's my sign convention? I can take my forward to be negative and my backward to be positive. But in this case, I'm taking my forward to be positive, taking my negative, the backward to be negative. So we need the relative velocity. So VR is the relative velocity. Now, mind you, they are moving in opposite what? Direction. This one is moving eastward and this one is moving westward. So that means we have VC, opposite direction. So VC minus what? VT. So VR is equals to, what is VC? 50 minus the velocity of the train is moving 70 kilometers. So we have minus 70 kilometers per hour. So VR is equals to what? 50 plus 70. So VR is what? 120 kilometers per hour. So they say, what's the relative velocity of the car with respect to the train? So it's 120 kilometer per hour. All right, we also have WAEC. We have WAEC 2007. Oh, sorry, WAEC. We have 2014, question 7. It said, which of the following pairs of physical quantity is made up of vectors? At the beginning of the class, I make a distinction between vectors and scalar. So it said, which of the following pairs of physical quantity is made up of vectors? A, we have speed and displacement. If you check A, speed and displacement, speed is a scalar, displacement is a vector quantity. B, then we have mass and force. Mass, the quantity of matter contained by a body. So mass there is a scalar, then force is a vector. So A and B is none of the answer. Then we have D also, momentum and length. Momentum is a vector, but length is a scalar. So D is not the answer. So the correct answer is C. The correct answer is C, which is displacement and acceleration. Displacement and acceleration. They have magnitude and direction. Or we can decide to say a train moves 5 kilometers per hour in the direction of 45 degrees northwest. So we have the magnitude and direction. So the answer there is C, displacement and acceleration. All right. Now we have another question. 2013. JAMB 2013. JAMB 2013. Question 3. It said the resultant of two forces. The resultant of two forces is 15 Newton. That means we already have the resultant. The resultant R is already given, it's 15 Newton. Now, if the forces are perpendicular to each other, and one of them makes an angle of 30 degrees with the resultant, find its magnitude. So, when you hear the word perpendicular, something like this, if you see this sign shows perpendicular. But when you see this sign, in mathematics or physics, this sign shows perpendicular. Then this sign shows parallel. When you see these symbols, this is parallel. This is what? Perpendicular. So we have the two forces. So let's say this is F1 and this is F2. Now F1 and F2, we're told they are perpendicular to each other. Perpendicular means they are at 90 degrees. Perpendicular means at 90 degrees to each other. But we're told that there's a resultant. We have a resultant of 50 Newton. The two vector has a resultant of 50 Newton acting at 30 degrees. That means we have the magnitude, which is the resultant, and the direction. Now the question says, the resultant of two forces is 50 Newton. If the forces are perpendicular to each other, and one of them makes an angle of 30 degrees with the resultant, one of them makes an angle of 30 degrees. Now the question says, find the magnitude. find the magnitude. So the magnitude is just, this is F2. F2 is at 30 degrees to the resultant. As mean they said F1 would have been to the vertical angle you have to the vertical. Maybe here is 60 degrees. If here, because the complement of 30, the complement of 30 is 60 degrees. Would have looked for F1. So what we need to find is what? F2. F2 is the angle it makes. F2 make an angle of 30 degrees to the resultant and in relation to the horizontal. 60 degrees is in relation to the vertical. So we have 30 degrees here. So definitely I can decide to cut here. If I cut here, this becomes F1. Why here? Here is what? F2. So how do we get this? For me to get F2, where R is, I can definitely use cosine. Why am I using cosine? Because I have my hypotenuse. If this is at 90 degrees, I have my hypotenuse, then I have what? Adjacent. So using SOHCAHTOA, cos 30 degrees is what? Adjacent over what? Hypotenuse. So definitely I will have cos 30 degrees. The adjacent there is F2. The hypotenuse is what? Is 50. So F2 is 50 cos 30 degrees. That should give us 25. Okay? Cos 30. Okay, sorry. We have 50. That's root 3 over 2. So we have 50 times 0.866. Sine 30 would have been 0.5. So F2, we have 50 times that value. So the answer is 25 root 3 or 25. Root 3 is 1.732. So definitely our F2, so you multiply, we have 43.3 Newton. So 25 root 3 is same thing as 43.3 Newton. That is the answer. Okay. So the option there is D. D, 43.3 Newton. Okay. More question. A boat travel. Okay, let's see. JAMB 1994. On vectors. Remember, vectors, they have magnitude and direction. All right. As I've earlier said, remember this is O3 school. And I told you our app is quite or completely available in Play Stores. The places you can get this app, this O3 school app, mostly on what? Play Store, on App Store. Please, feel free to download and activate. There you have more problems and their what? And their solution to guide you on your forthcoming exams. Now, another question here says, JAMB 1994, question 2. A boat, we have a boat. The boat floats on water from the law of the flotations. Now, a boat float or a boat travel due east. So let's say this is the boat. Due east. When you hear the word due east, try and create your cardinal point. The reference point is the north. So north, south. You have west, you have east. East. Now, a boat travel due east. Due east. So you draw here down. Due east. This is due east. At a speed of 40 meters per second. So this is 40 meters per second. When you stop here again, you have a new reference point, which is the north. At every point in space, you have your new reference point, which is the knot. If I move from this board to this part, I'll have a new knot. If I move to this point, I have a new knot, which is the reference point. Now, the question says, a boat travels due east at a speed of 40 meters per second across a river flow due south. Now, the river flow due what? Due south. Now, this is the river flow. The river flow due what? Due south. The boat moved due east, while the river flow is due south. Coming here, you have a new reference point. Now, the question says, what is the resultant of the boat? Now, if this is the boat moves from here to this point, and the river side, the river flow due what? Flow due south. Now, for us to get the resultant can be formed in this form. If these are our resultant, because due south, it flows at 30 meters per second. So using Pythagoras, if this is 90 degree, so definitely our R square will be 30 square plus 40 square. So 30 square is 900 plus 40 square is 1600. 1600, so R becomes 2500. So the resultant is square root of 2500. The resultant is 50. So you have 50 meters per second. So let's see our options. The answer is C. The answer is C. Okay, let's see more questions. Now, 2013, question 4. 2013, question 4. The question says, the pair of physical quantities that are scalar only are dash. The pair of physical quantities that are scalar only are dash. You have impulse and time, momentum and moment, length and displacement. So the pair that are scalar is volume and area. The volume and what? And area. Volume can just be added numerically. Maybe 4 centimeter cube of petrol plus 4 centimeter cube of petrol. If you add, you have 8 centimeter cube. Can just be added numerically by additions. So the correct answer there is volume and area. Because if you pick D, you have length and displacement. Automatically, displacement is a vector quantity. Impulse is a vector quantity. Then you can pick C. C says momentum and moment. Moment and momentum, they are vector quantities. Okay? So the correct answer is B, which is volume and area. Now, 2019 or 2019, question 11. I've explained this before. It said a single force which produce the same effect as a set of forces acting together at a point. Yes, I've explained it, where I use 3 persons and a single man that has a force of 14 Newton. So A says component, B equilibrant, C resultant, D resistance. So what's the answer? Okay, the answer is C, which is what? Resultant. Resultant is a single force which produces the same effect as a set of forces. I told you that if, let me repeat what I said before, a single man has a force of, let's say, 14 Newton, a single person. Then we'll have 3 other persons weighing 20 Newton, and having a force of 20 Newton, 10 Newton, and 10 Newton. The same task executed by these three persons can also be executed by this man that has 14 Newton. So the single force of 14 Newton, when you add all these forces together to produce a force of 14 Newton, that is the resultant force. So a single force which produces the same effect as set of forces. What are the set of forces? We have 20 Newton, 10 Newton, this other set of forces. So acting together at a point, that is the resultant. So the answer there is C, which is resultant. 2019, question 11. Okay, we have another one, 2018. 2018, 2018. Question 1. Oh, it was even the first question. Now, he said, in a school compound, we have a school compound. A girl walks 40 meters due east. So let's assume this is the school compound. The girl is somewhere here. This is the school compound. The girl is somewhere here at point A in the school compound. A girl walks 40 meters due east. So your reference point, before the girl starts the movement, let's assume is at the body is at rest or static. So the reference point, you have the north, south, and the west, and this is east. East. We need to understand that in a school compound, a girl walks 40 meters due east. So let's explain this. We have east, you move due east, 40 meters. After attaining the distance of 40 meters, we have a new reference point. Don't forget, you have your new reference point. Now, a girl walks 40 meters due east from the laboratory to the staff room. So let's say this is the lab. Point A here is the lab, and this is the staff room. The staff room. To submit her report. She then turns and walks 30 meters due north. So she walks due north. Due north for what? 30 meters. So here is 30 meters. Okay, shouldn't be way longer. So let's say 30 meters. When she covers a distance of 30 meters, you have a new reference point. Now, she then turns and walks 30 meters due north to her classroom. So this is her classroom. So what are the points? From the lab to the staff room. From the staff room to the classroom. Now, determine the magnitude of her displacement from the lab. From the lab, she starts here. So this lab is called the initial point. Initial point. Then the classroom is called the final position. The final position. So take the magnitude. The magnitude is here, R. So definitely we have a right angle triangle. So without even solving, our answer should give us 50 meters. But let's solve using Pythagoras. R square becomes what? 40 square plus 30 square. So R square is, you have 40 square to be 1600. So 1600 plus 900. So R square is 2500. So 2500. So the resultant is square root of 2500. And that's 50 meters. So the displacement is 50. Displacement is 50. So the answer there is C. The answer there is C. Okay. Let's see 2022. Physics objective 2022. 2022. Question 26. If a man walks 40 meters due west, a man walk 40 meters due west and 30 meters due south, calculate his displacement. So we have a man walks 40 meters due west. So before the man starts, he must have been he's at a particular point. So let's say this is the man. The man walks 40 meters due west. Okay, so since it's due west, so let's say here there's the part north. He walks 40 meters due west. So this is 40 meters. So when he's here, he has a new reference point. And 30 meters due south. So from here, he walks 30 meters again. He walks 30 meters again. So this is 30 meters due west. So due south. If a man walks 40 meters due west, initially here, he was due west. So this is west. He walked due west. When he got to this point, he has a new reference point. Then he turns and walks 30 meters what? South. Calculate his displacement. So we have displacement. Okay. So let's say we have an angle here, angle theta. Angle theta. If here is theta, let's say here is alpha. So we need the magnitude. Now, how do we get the magnitude? For us to get the magnitude, use Pythagoras. So you have to be conversant with Pythagoras. I think Pythagoras, you start doing Pythagoras from primary 4. So you have to be conversant with Pythagoras. So we have resultant again. R square is what? 30 square plus what? 40 square. So that will give us 900 plus 1600. So 2500 R square. So definitely our resultant is square root of 2500. So we have 15 meters. But if you check the question, we have 50 meters, 53 degrees southwest. We also have 50 meters, 37 degrees. So that means we need to get what? The direction. Now, how do you get direction? If we are considering theta, definitely we can use tan. Tan theta is opposite over adjacent, the opposite. Now, if theta is here, let me clean this. This is 40 meters. If theta is here, the side facing theta is 30. So that means 30 over the adjacent becomes 40. So 0 will cancel 0. So tan theta is 3 over 4. Tan theta, 3 over 4, that's automatically 0.75. So theta is tan inverse of 0.75. So if we do tan inverse of 0.75, we have approximately 37 degrees. But if we check, this 37 degree becomes, it doesn't lies with the reference point. So that means alpha will tell us the direction, because theta here is not lying with the reference point, it's lying with the horizontal and the magnitude. So definitely we need to find in terms of southwest. That means we need to find the complement of 37. That should be 53. So that means alpha, let me wipe this part. So that means alpha is 90 minus theta. Because for a complementary angle, you sum of two angles to give you 90 degrees. So alpha is 90 degree minus theta. So that alpha is 90 minus theta. And theta is approximately 37. So you have 37 degrees. So alpha is 53 degree. Now, it lies with what? This is south. So that means we have 53 degree southwest. 53 degree southwest. So the correct option there is A. The answer is A. Option A. Option A is what? 50 meters, 53 degree southwest. Let me repeat. This is theta. This is alpha. Theta gave us 37 degree. So definitely alpha will be 53 degree because the complement of theta is alpha. And from the option, alpha makes an angle of 53 degree southward, southwest, southwest. All right. That'll be all for now for this section of physics. Thank you.